We are Cell Solutions Incorporated, a team of 4 biomedical engineering students at Arizona State University. We are developing a new tool for stem cell differentiation.
It's difficult to obtain large amounts of human tissue today. The translational gap between human and animal tissue is very large. Stem cell engineering offers a path to bridge these two together.
The tissue engineers want to be able to direct the stem cell differentiation. However, these methods are often unpredictable and fail to recapitulate the endogenous microenvironment. Global tissue engineering and regenerative medicine markets are currently valued at $23.2 billion and $4.25 billion. They're expected to exceed upwards of $95 billion and $25 billion over the next decade, respectively.
Projected customers include academia and universities, research facilities, and R&D departments of regenerative medicine companies. Our Optogenetic Photomask System is optimized for a 24-well plate, which was requested by many of our customers. Some customer needs include sterilizability and a snug but movable fit between system components. This is the spacer. It has 24 holes of the same diameter and spacing as a 24-well cell plate. The spacer goes between the light source and the photomask. Its purpose is optical insulation so that light from our light source cannot escape and outside light cannot enter the system. It has a 0.5 mm groove lining its outer edge. Here is the photomask. It was printed with a simple star pattern with each single star corresponding to a well on the cell plate above it. On the underside of the mask, there is a 0.7 mm indent which allows for the spacer to be secured under it. On the top, there is a 0.5 mm groove which fits into the indent lining the outer edges of the cell plate above it. The spacer and the photomask are meant to fit together with the photomask on top of the spacer. To verify that this fit was good, we aligned the indent on the underside of the photomask with the groove on top of the spacer. They fit together snugly as desired. For a quick verification regarding how the system fits together, we stacked them up and evaluated their snugness. One problem that we intend on correcting is the looseness between the photomask and the cell plate. This looseness could introduce difficulties in practice. Aside from this issue, the sandwich-style system fits together well and looks feasible for use in cell culture. For validation, we are speaking with end users and our team's mentor. This is the beta prototype for the light source of our system.
When each transistor is turned off, it will be collecting current from the 5-volt supply source. To ensure safety throughout product development, our transistor components are rated with a collector current of 500 milliamps. Using an Arduino and transistor, our customer base can design experiments for its product to determine the amount of length of light exposure each row of LEDs can produce.